Welcome back to another episode. Today we're going to be looking at fractions, Postvenska heter Brockform. Let's get started. So today we're going to look at what are fractions. We're going to look at equivalent fractions. Then we're going to look at how do we go from Brock form to decimal form. How do we go from fractions to decimal form? Then we're going to look at how do we go from fraction form to mixed form, or we say Brock form to blended form. Then we're going to look at how do we add and even subtract fractions. I found in my classes a lot of students are a bit confused with fractions, so I felt like this video could be really helpful for a lot of people. So, what are fractions? When you think of a fraction, you think of it's a part of something. It's not a complete set. You're looking at part of a whole. So let's look at this picture, for example. Here we have one complete whole. If you have one chocolate bar, you have the whole thing. However, when we go down to the next step, we're breaking the chocolate bar into two pieces. This is the number 2 here. It represents how many pieces of the whole we have that's cut into. Well, we have 2 pieces, and this one piece is 1 out of 2. So that's why it's written as 1/2. And you can get the whole chocolate bar if you have 2 halves, or 2 1/2. We see that this rectangle is the same size as 2 of these rectangles. And as we continue down, we look at, well, this is breaking into 3 parts. We know that if we have 3 of these, we're going to have the same as 1 whole. And the pattern continues on all the way up to a 12. We have 12 pieces. Each of them represents 1/12, or 1/2. So if we have 12 of them, we have 1 whole. So we write fractions as a combination of a number written over another number, showing that we have part of a whole. So we see fractions like this. Well, they have names for numbers, and we're going to look at the first number. The number 1, it stands on the top of the fraction. This is called our taljare, or we say this is our numerator. Or if we're really lazy, we might just say the top number. Down below, we have our 5. This is our namnare, or we say the denominator. And when we get really lazy, we say this is the bottom number. We might go between these terms in this video, so it's good to know before we start. So a fraction looks something like this. Let's look at the picture above. Here we have 1 chocolate bar. In this fraction, we have 1/5. So this chocolate bar can be broken into 5 pieces. We still have the whole chocolate bar there. However, it's just broken into 5 equal sized pieces. And if we look at 1/5, here is 1/5. Can be written like that. This is also 1/5. All of these are 1/5. So 1/5 can be represented like this. Sometimes we need to look at equivalent fractions. Equivalent fractions. Well, what does that mean? Let's use this diagram to illustrate. So in the last example, we have a chocolate bar broken into 5 pieces. and each piece represents 1/5. Or we can say 1/5. Let's again look at the next picture. Well, we have the same size chocolate bar. However, they're cut into even smaller pieces. And if you're able to count how many pieces there are here, there are 2 pieces for every 1 piece. If you count really quick, you know this will be each represent 1/10 or a 1/10. Good. I've highlighted the bottom piece here on the chocolate bar. Here we see, it's a bit hard to see, this is 1/5. All right. When we look below, we see that 2 of these pieces, we have 1/10 plus 1/10. That's going to give us 2/10. And we see that in both pictures, in both chocolate bars, it's the exact same size. So if we were to compare these 2 chocolate bars and offer the same person 1/5 of this chocolate bar or 2/10 of this chocolate bar, the answer shouldn't really matter because they have the same value. And when we write these fractions beside each other, we can say that these are both equivalent fractions. Sometimes we don't have the picture to illustrate, so we need to understand how do we go from 1/5 to 2/10. And let's just look at the bottom number. So you ask yourselves, how do you go from here to here? And think about what I can multiply 5 by in order to get to 10. And you should notice that 5 times 2 is equal to 10. And when we deal with fractions, we have a tendency to do whatever is done to the bottom of the fraction, we also need to do to the top of the fraction. So we know that 1 times 2 also equals 2, which is 2/10. We can continue this pattern if we look at 1/5 and instead we multiply it by 3. This will give us 3/15. If we multiply the numerator and the denominator by 4, for example, we'll have 4/20. These are equivalent fractions because they have the same value. If someone was offered 1/5 of the chocolate bar, 2/10 of the chocolate bar, 3/15 of the chocolate bar, or 4/20 of the chocolate bar, the answer should not matter. The only difference is the chocolate bar is cut into smaller pieces when the number on the bottom increases. These are equivalent fractions. So, sometimes we need to deal with fractions in decimals. Let's look at the example 1/2. To go from fraction to decimal, you need to just look at this fraction as a division. You're asking yourselves, what is 1 divided by 2? So you ask yourselves, how many times does 2 go into 1? Well, the answer is 0. 2 is too big to fit into 1. Think about it as you have 2 people that need to fit into 1 chair. It just doesn't work. So when we put our 0, we need to continue our work. So let's add a 0 here, and let's add a decimal here. And then we ask ourselves, how many times does 2 fit into 10? And the answer should be 5. Because 5 times 2 is 10. Here we have it, 0.5. So the best way to go from fraction form to decimal form is to use division. However, what happens when we get to the case where we have a decimal and we need to go to from decimal to fraction form? Well, this is really important to know our place value. And in a previous video, we talked about Platzwarden and that each number has a specific place value. I'll include this video in the description below. So when we look at this, this is our tiondel, our tenths group. So if it's 3 groups of 10, we have a tenth times 3. Well, we have 3 tenths. And when we multiply fractions, we multiply 3 times 1. And we keep the bottom number the same. So our final answer is 3 over 10. We have 3 tenths. What if we had another example where we had 0.75? Let's look at what we did in the previous example. We know this is our tiondel, and this is our hundredel. Or we say in English, our hundredths. So in that case, we have 75 hundredths, which is the same as 75 over 100. Yeah, okay, we have a fraction, but sometimes the question might say, make sure to simplify or find an equivalent fraction. And what we need to do at this point is we need to look at 75 over 100. And we need to find out what can we divide such that, can we divide this by a number and this by the exact same number so that we get a fraction that is equivalent. However, the numbers on the top and the bottom are lower. So what you can do is you can look at what are the factors of 75 and start listing the factors of 75. So numbers that multiply to give you 75. Well, I know 1 times 75 works. I know that 5 times 15 works. And you can go on and on and on, okay? You can also list the factors of 100. And you can find that, 1 times 100, 2 times 50. And you can continue on and on and on. So these are for people who know their multiplication tables. But I know there's some people out there that really struggle with multiplication. So this is the tool to use for those who don't want to think. You look at these two numbers and you say, what can I divide them by? So first you can start with, can I divide it by 2? If that doesn't work, move on to dividing by 3. And continue this pattern until you cannot divide any further. This takes a long time, so it's recommended that we use this strategy. So if we were to continue this, you should notice that we need to look for the greatest common factor. And the greatest common factor is the largest number in the factors of 75 and the factors of 100 that they have in common. In this case, it's 25. So that is what we're going to do here. So when we divide these by 25, 75 divided by 25 gives us 3. 100 divided by 25 gives us 4. Since we found the greatest common factor here, we know that this here is the simplest form. It's the simplest equivalent fraction of 75 over 100. So sometimes we need to go from fraction form to blended form. And what I mean by blended form is mixed form. I'll give you an example of a blended form. Maybe we have 1 1/3. It's mixed because we have a whole number or heletal, and we have a fraction in block form. And we're all familiar with the fraction, for example, 1/5. Sometimes we need to go from blended form to block form or block form to blended form. Let's take one example. If we have a fraction like 22/5, when this number is bigger than the bottom number, then we might be asked to find this in mixed form. And first, what you ask yourself is, how many times does 5 fit into 22? And when you count by 5s, you realize that the answer is 4. So we're going to write a big 4. Then we ask ourselves, how many do we have left? Hur många kvar? So 5 gånger 4 lika 20. So 22 minus 20 lika 2. So we write the remainder here. This number stays the same. And this is how many times 5 fits into 22. 4 whole times. This is our whole number. So our final answer is 4 2/5. Sometimes we are given an answer here in mixed form, and we need to go to block form. Pretty simple. We're going to start here. We're going to say, what is 6 times 5? 6 times 5. Then we're going to add the remainder. And whatever that is here, it turns out to be 1. Then we write the number here as 5 because remember we stays the same. 6 times 5 plus 1, we end up getting 31/5. And to double check your work, you could say, how many times does 5 fit into 31? Oh, 6 times, 1 remaining, and 5 on the bottom. So here are the methods and strategies we use to find block form to blended form and the other way around. Adding and subtracting fractions. We all know that if we have 1/2 plus 1/2, we can add these fractions. The key to this is the denominator must be the same. Or we can say that the nämnaren must be the same. So when we do these, yep, 2 is here, 2 is here, good. Now we add the top numbers. And this is pretty easy, which is 1 whole. However, it gets a bit tricky when we get something like this. We have 1/2 plus 1/4. This is where you need to look at the bottom number here and the bottom number here. You ask yourselves, how do we make these two numbers the same? And sometimes you're helped out a bit. You got a number here like 4. You look at 2 and you say, well, can I make 2 to 4? Or can it become 4? And I know that, yeah, I can multiply that by 2, which means we need to multiply the top by 2, because whatever we do to the bottom, we must do to the top. So we know that this is the same. 2 times 1 is 2. 2 times 2 is 4. And we didn't do anything here. 2 over 4 is an equivalent fraction to 1 over 2, as we discussed earlier. Now the bottoms are the same. Good. Now we can add the tops. Keep the bottom number the same. Our final answer. However, for the lazy person, some of us don't want to think. What you can do is you look at this number and you say, well, 4, I'm going to multiply this by 4 and this by 4. You look up here, this number's a 2. I'm going to multiply these numbers by 2. We end up getting 4 over 8 plus 2 over 8. The bottoms are the same. Now we add the tops. We get 6 over 8. And at that point, you look to say, hey, can I simplify this fraction? Or can I make this number here and this number here a smaller number by dividing them by the same number? And you can do that if you divide by 2, divide by 2, and you get the same answer as before. The same rules apply when you subtract fractions. The bottoms must be the same. Multiplication, division, I believe these are a bit easier than adding and subtracting. If we have 1/2 times 1/4, it's easy. We multiply the tops, multiply the bottoms, and our answer is 1/8. If we divide, well, there's one trick involved. And in that trick, we are going to flip these numbers and change this to multiply. Take a look. Keep the first fraction the same. You're going to multiply, and then you're going to write this fraction upside down. And since we know how to multiply fractions, we can use our strategy that we learned here to finish the question. Our answer is 2. This is multiplying and dividing fractions. So I hope this video was helpful. If you found it helpful, please don't forget to subscribe and like this channel for more videos. Take care, everyone.